Okay, last lesson we started looking at this. This bit here's a recap. What to do if you don't know the population mean and or the population standard deviation. This is the central limit theorem here in a nutshell, that the distribution of sample means, whatever distribution x comes from itself, is normal mu sigma squared over n. If we don't know mu, we use x bar instead, because x bar is an unbiased estimator for mu. The derivation for that can be found in the textbook, because the expected value of x bar is mu. We can write that down using this hat notation. A hat over something means it's an unbiased estimator for. So the hat over mu means an unbiased estimator for mu. Then we said, well, what happens if we don't know sigma squared? If we don't know sigma squared, our unbiased estimator for sigma squared, which is sigma squared with a hat over it, is our sample variance, but with this fiddle factor at the front. And again, you don't have to worry about the derivation of that, but you do have to know the result of that. There's a slight issue here in that some textbooks call this thing here, which I in words would call the sample variance s squared, and I call that s squared. However, your OCR textbook calls it with the fiddle factor s squared. And this is confusion between different authors, effectively. Rob?
Why do you have the little n-1 thing for the factor?
Where's it come from?
Yeah.
It comes from the derivation which you saw a few minutes ago. Okay? Is the answer, which is also in the book. So, sigma, I will use notation like this. The unbiased estimator for sigma squared is that fiddle factor times by s squared, where s squared is the variance of the sample. So that's the notation that I will be using. So I'll just pause out there in case everybody wants to make any notes, and then we'll carry on.